Imagine you're developing a new product and trying to make it more sustainable. You want a material that performs like traditional plastic, but has a much lower environmental impact. This is exactly where PLA, polylactic acid, becomes an important solution. PLA is a biodegradable thermoplastic made from renewable plant sources like cornstarch or sugarcane. Unlike petroleum-based plastics, it comes from biomass, which helps reduce the overall carbon footprint of manufacturing. What makes PLA interesting is that it combines sustainability with strong material performance. It offers good tensile strength, excellent printability, and biocompatibility. Under industrial composting conditions, PLA can break down into carbon dioxide and water, making it a promising material for environmentally responsible production. Let's start with the foundation. PLA, or polylactic acid, is a biodegradable thermoplastic polyester made from renewable resources like cornstarch or sugarcane. Unlike petroleum-based plastics, PLA originates from biomass fermentation, which dramatically reduces its carbon footprint. But here's something many people don't realize. PLA isn't just biodegradable plastic. It's actually a high-performance engineering polymer when manufactured correctly. It offers high tensile strength, excellent printability, biocompatibility, low warping during processing. That's why it's become the default material for FDM 3D printing, but its use extends far beyond prototyping. Another important point is its environmental behavior. Under industrial composting conditions, PLA breaks down into carbon dioxide and water, making it a viable component in the circular materials economy. But remember, this only happens in proper composting facilities, not typically in backyard compost. This is an important nuance many companies miss when making sustainability claims. The production of PLA generally involves three major steps. First is fermentation. Plant-based raw materials such as corn are fermented to produce lactic acid. Second is polymerization, where these lactic acid molecules are chemically converted into long polymer chains using a process called ring opening polymerization. Finally, the material goes through compounding, where the polymer is processed into pellets or filaments and modified with additives to improve its properties. This stage is especially important because it determines how the material will behave during manufacturing. PLA is now widely used across several industries. One of the most common uses is 3D printing. Because PLA prints easily and has minimal warping, it has become the most popular filament for FDM printers, typically printing at around 210 degrees Celsius. PLA is also used in biomedical applications, including surgical sutures, drug delivery systems, and tissue engineering scaffolds due to its biocompatibility. Another major application is sustainable packaging, where PLA is used for compostable food containers, films, and eco-friendly bags. When sourcing PLA, choosing the right supplier is critical. First, look for quality certifications such as ISO 9001 and ASTM D6400. These ensure that the material meets quality standards and compostability requirements. Second, evaluate the range of PLA grades offered. Different grades are designed for different applications. For example, medical-grade PLA focuses on high purity, while industrial grades are optimized for cost and stiffness. Finally, strong suppliers usually provide technical support and material data, which is extremely helpful when scaling manufacturing. Not all PLA materials are the same. Different grades are designed for different applications. Medical-grade PLA offers very high purity and controlled molecular weight, making it suitable for implants and biomedical devices. Pharmaceutical-grade PLA is designed with very low residual monomers, which is important for drug delivery systems. Industrial-grade PLA is more cost-efficient and commonly used in packaging and prototyping. There is also high-heat PLA, which is engineered to withstand higher temperatures, making it suitable for applications like food containers. Understanding these grades helps manufacturers choose the right PLA material for their specific performance and regulatory needs. Several companies play a key role in supplying PLA in Canada and the United States. Distributors such as Nexeo Plastics, Entech Polymers, and Bamberger Amco provide access to high-quality PLA resins and specialized grades for industries like medical devices, packaging, and 3D printing. Working with established suppliers helps ensure supply chain stability and consistent material performance. PLA is one of the most widely used materials in 3D printing. It is especially popular in FDM printing because it is easy to use and produces reliable results. Typically, PLA prints at around 210 degrees Celsius and has very low warping, which helps maintain the shape and accuracy of printed parts. Because of these properties, PLA is widely used for rapid prototyping, product design, and educational applications. Today, many suppliers also offer enhanced PLA filaments with improved mechanical strength, allowing engineers to create stronger and more functional prototypes. The demand for PLA is growing rapidly across North America. This growth is driven by increasing restrictions on single-use plastics, advances in bio-based materials, and improvements in recycling and composting infrastructure. As new blends and processing technologies continue to emerge, PLA is expected to play a major role in the future of sustainable manufacturing. PLA represents more than just a biodegradable plastic. It's a material that bridges sustainability, advanced chemistry, and modern manufacturing. And with the right suppliers, certifications, and material analysis, companies can confidently integrate PLA into their products while moving toward a more sustainable future.